Thank you. Hi, everyone. My name's Jared. I work for Fuse Technical Group. I'm very excited and honored to have the opportunity to speak with you today and share some of what Fuse is working on to contribute to the conversation and the development of in-camera visual effects technology. To talk a little bit about Fuse, we offer full-service production across all markets all over the world. If you have a complex or seemingly impossible problem, please give us a call. A little bit background on me. I'm a creative technologist and developer. Primarily, the bulk of my work is in in-camera visual effects technology, however, with experience over a number of different markets, developing bespoke playback, display, and content systems for productions. Today, I'll talk to you a little bit about kind of a little bit of the brief, condensed version of the history of IC VFX technology, followed by a demo of some of the developments that we're working on here at Fuse. I'll start off with the obligatory Arthur C. Clarke quote, any sufficiently advanced technology is indistinguishable from magic. However, I'll add the addendum, when it works. There's, as we all know, technology not working is far less than magic. What I'm going to do now is kind of step through some of the iconic films throughout history that have utilized in-camera techniques, kind of where we ended up now and where things may be headed. So starting off with the classics, North by Northwest, which made extensive use of rear projection to achieve other dangerous or otherwise challenging shooting conditions. This iconic, the airplane chase scene through the cornfield, followed by none other than 2001: A Space Odyssey, which is personally my favorite example, and I think was, as we know, far ahead of its time, but in ways that are often not even publicized. This made use of high-resolution, on-location photography to recreate, deserts and sort of prehistoric man inside a studio. And one of the aspects of it that's very unique is actually the lighting array starts to take the form of what we now consider the standard of an LED volume, where we have a high-resolution in-camera display element, in this case front projection, in tandem with interactive or dynamic lighting to create a very, very realistic image. Jumping forward just a little bit, we have Oblivion, which made use of digital projection and digital playback technology and array photography to achieve an otherwise impossible shooting condition. And this, for me, stood out. This is one of the movies when I saw the behind the scenes, as studying projection at the time, and it was a major influence on the trajectory of my career, but also just an excellent example of the early implementations of these technologies. You can see here some of the sets and shooting conditions that were part of the production. Following up, we've got Murder on the Orient Express, which is among the first to use LED for in-camera capture, and probably make the argument this is the first LED volume in a lot of ways. This LED constructed around a train in order to transport the audience and capture the imagery in camera. And this was also shot on film. Following up brings us to First Man, which was also similar in a sense that we start to get into sort of the half-round shaped LED walls. This involved a combination of offline rendered imagery, historical imagery, and then also started to work in motion tracking in order to bring more interactivity between the production and the screen. Leading from there, we have The Mandalorian, which we all know very well at this point, is the iconic production of the virtual production in LED volumes, and really set the tone for today, all the way to today, as far as what the shape of these productions look like. And then productions such as Fallout, which used LED volumes for a significant amount of its principal photography. You can see some of the images here. So I show this and pick these images specifically because these are all examples of successful implementations of the technology. Not all productions have been so lucky. As we go through the history of this technology, the complexity and thereby the creative possibilities have increased exponentially. And you kind of hit a point, and at least in my experience, the pervasive kind of question is, like, where do we go from here? Also, how do we make it easier? Because we all know there's many, many, many moving parts in these productions, and it's a lot of people taking the time to take a step back and kind of examine that and see how we can improve the process and increase the viability of this technology. As it's well proven that it can be a valuable asset in production, however, can also be a total nightmare if not implemented. I wouldn't say correctly, but not implemented intelligently. So basically, long story short, is taking an opportunity to talk about and get back to basics a little bit about what we're capturing, why, and how. So at Fuse, we have chosen to kind of develop or dedicate development efforts towards a display and playback engine specifically for that purpose, which we're calling Iris. We're going to move into a technical demo, kind of part of the presentation here. I'm going to be shouting instructions at my colleague Kaiwen, who's at the back of the room. Everyone wave to Kaiwen, who's operating the system. So cool. Let's go ahead and dive in. So Iris is a ground-up reconsideration, rebuild, if you will, of rendering pipelines for in-camera visual effects. We place highest emphasis on image quality, also system performance, and integration with existing on-set technologies. So to kind of rattle off some of the key features before we dive into the images, first up is full ACES compatibility, both on input and output. We use physically based camera models to render the images, meaning that we take measurements and otherwise have a detailed understanding of the camera and lens and use that directly in the renderer. We have an amount of local AI processing for certain effects. We'll get into that in a minute. So direct lighting system integrations, so you can generate and otherwise shape lighting control values directly in the system. And then we also have built-in support for a number of different open source frameworks, such as Color Science, OpenCV, and OpenColor.io. And that list is growing. The system is being developed in collaboration with Panavision and members of the ASC. And we are implementing on productions now, however, on a very much case-by-case basis. So what we'll do today is I'm going to step through 4 different sort of proof of concept scenes that we've developed internally, both for the purposes of developing the system, but also doing things like this, where we can kind of share and start a conversation about new and interesting ways to approach this work. One thing I do want to call attention to as we get into this is that everything you'll see today is rendering on a single computer. There's a high emphasis placed on performance. So we're able to render, this is a 4 output volume on a single machine. So Kaiwen, let's go ahead and jump into the warehouse scene, please. Loading, there we go. Cool. So this scene, where to start? So this scene started its life as an HDRI. For those of you in the CG world, you probably recognize it. This is a pretty common royalty-free asset circulating on the internet. The difference here is that we've taken it a step further and dimensionalized it. So Kaiwen, can you kind of rotate the scene around a little bit to maybe see one of the columns upstage? Oh, that works too, perfect. And you can turn off the depth of field, please. Great. So this image started its life as a single 360-degree HDRI, and then after about 2 days of processing, basically, to get rough dimensionalization of the space, we can now use it in call it quote-unquote standard virtual production workflow, where we can get parallax and get depth, But because the system places particular emphasis on image quality, we're able to retain all the dynamic range of the source image as well. And in fact, throughout the whole pipeline, pretty much don't touch the color pipeline unless we're asked to, and then remap very specifically to the display response at the very end of the pipeline. So there's almost no loss in actual quality throughout. And because we've dimensionalized the image, we can start to layer in depth-based effects. So Kyron, can you flip the depth of field back on? And then could you rack through focus, just in and out? There we go. And then back out. Cool. So can you rotate us back around too, facing back the other way? And on the sides here, we don't have a camera for the demo. So these are some images shot probably about a month ago on a RELF Mini with Panavision lenses. And yeah, so demonstrating because we have full control over the color pipeline and can design it very specifically for this purpose, we can take all of the luminance information of images captured by professional stills cameras, cinema cameras, whatever, leverage all of the talents of the cinematographers and people that we collaborate with on these productions frequently in order to deliver and shorten the timeline from capture, processing, and getting onto the LED screen, which is a principal challenge in actually implementing this technology in production. It's our hope by kind of shortening that pipeline and doing the hard work to kind of figure out these content specifications and recommendations for process, we can open the door to the lower budget or productions that may not have otherwise considered approaching this technology. So yeah, this is an example of a fully static scene. So it's just a still image, but as a result, it's a lot quicker to turn around. And it can be captured by a single camera with a single photographer. And in fact, it's already a very common workflow component of on-set day-to-day anyway, shooting HDRIs. Just another way to implement. From here, let's load up the bakery scene, Kevin. Cool. So this one, and that very quick scene loading as well. The assets themselves are naturally highly optimized because most of the realism that we're relying on is captured in the camera to start with. However, this scene, which introduces some creative constraints in the sense that you can't necessarily make sweeping lighting adjustments to your scene, but frankly, in production, you don't necessarily want that flexibility. In our experience, most of the artists we work with are perfectly happy to make the decision well out ahead of time so there's no surprises on the day. What tends to be the challenge is having the tools in place to help them actually make that decision from an educated position. So we're working on ways to kind of smooth that out. But this scene does demonstrate an example of where we're able to combine different source assets. So this interior is actually still derived from an HDRI, very similar to the last scene that we looked at. However, the plate outside the window is shot completely different time and place with a cinema camera. And you can see some of the lighting and dappled lighting on the ground. That's actually composited in after the fact, in this case in Blender. And then all of the dust particles in the room are generative. So we're able to combine and composite in a 3D context all of these different elements. And then once you layer in the depth effects and the camera-based effects, it really shortens the road to oops, I had the wrong video there, to a realistic in-camera image. As you can see in the video here on the wings, you get very natural bloom and lens as well from the high dynamic range images. Because it's all dimensionalized, depth of field and everything feels about as natural as you can hope for. And at the end of the day, the asset payload is absolutely minimal. And in fact, looks very similar to what a typical VFX comp looks like in terms of layers, cards, things like that. So it widens the gamut of different DCC tools that can actually deliver into the pipeline. It makes it a lot easier for a studio that works in Nuke or Fusion or Houdini or what have you to deliver into the system more directly. From here, let's jump to Sea Ranch, please. So this is another example of plate capture. So this is just single camera. In this case, I think it was a Canon R5, so nothing very fancy. However, some of the additional features in the system, let me go into my next thing. First and foremost, we have real-time color grading. So we can set up different images, and because we're still working with the original full dynamic range of the image, there's a lot of flexibility in what you can do in terms of actually, in terms of on-set grading. In addition to that, we start to work in AI depth estimation, and then that re-enables the ability to have all the depth of field and depth-based effects that we were looking at in the other dimensionalized scenes. However, the provenance is from a single still image. So Kyron, can you just demonstrate kind of racking through the focal? And the focus simulation also includes bokeh, so you can start to kind of layer in all these different things to basically curate these effects to feel like natural camera response. So now, Kyron, if we just throw in here's the actual depth map. So that's what is spit out by Stable Diffusion, and then we use to achieve these effects. And then from here, can you throw some bloom on? And then maybe back down on the exposure a ways. On the exposure. Or not the exposure, it's all good. And lastly, that is also inclusive, oops, let me get back on track here. HDR post effects. So all the post effects that we introduce are all HDR compatible as well. So yeah, basically trying to kind of shorten, simplify, and curate certain aspects of the pipeline to make it easier to get images, photographable images onto the screen. And then lastly, some of the most exciting research going on right now is in the realm of sort of volumetric content formats, Gaussian splats, NERFs in this realm. We do have native support for G-splats, which are loading up now. Might need to turn that around, Kaiwan. There we go. Can you turn off the depth of field? Perfect. So this is actually the side of my house. This is derived from about 100 different photographs taken down this alleyway, taken over a course of a minute or two, really. It takes about 2 hours to process, and the result is a highly detailed volumetric representation of that space. When we first started experimenting around with this, it was astonishing right away. Like, for instance, that chain link fence, the cables, the foliage, all of these represent a worst case scenario from a compositing and a processing standpoint when it comes to trying to add dimension to an image. And with this workflow, it happens essentially automatically. So we've just been blown away pursuing this technology and trying to figure out how to support the rendering pipelines better. And it's challenging because the research is happening so quickly. It's almost every week that there's a new paper or a new development. And right now, many people chasing moving splats. But because of the way that the system is built, we can composite in video elements and other asset types to introduce movement into the scene. So you can start to pick and choose, like, okay, maybe my up-close subjects are splats, and then a little further out, we're into plates. And if all of that color imagery and the color management is sorted out, you can start to unify all of these things in a single system. So this is an example of an internal proof of concept, which you can see we're moving down the alleyway here. And then can you back all the way back out, Kaiwan? You can see that in areas where there's occlusion, it starts to fall apart a little bit. But if you have sufficient coverage in your initial capture, it's very flexible. Could see this being very useful for reshoots, for inserts, for just as a way to have a safety where if you need to revisit a scene or a location, you can do so in the safety of an LED stage or LED volume. So from there, that concludes the sort of tech demo and the scenes that we wanted to look at. Again, to summarize, this is a custom ongoing development. We build very specifically to the needs of production, of a collective, almost a decade or almost a century of experience amongst people on the team here at Fuse. So every time we do a show, we try to take what we learn, re-ingest it into the development pipeline, and just keep making it better and better and better. And this represents kind of the latest generation of that work. Very excited to have the opportunity to share it with you here today. I blew through that 10 minutes faster than I thought, so I'll go ahead and open it for questions. Yeah. Any questions?
Hello, Jared.
Hey.
I was just wondering what you captured the Gaussian splat you showed with, and then I had another question related to some of the color. Oh, in the color grading features you've built, is that a suite of tools you've built or integrated from another tool like Live Grade, Onset Resolve, etc.?
The splat was captured with a red Komodo, and I did it in the time-lapse mode, so you could have just better control over shutter speed. It's vital that there's no motion blur in the capture or per frame. So yeah, and that also helped to retain dynamic range, which is an enormous challenge with all these neural and volumetric and AI-related stuff. So shooting it on a cinema camera allowed us to retain that range with the log curve. And then, sorry, what was the second? Grading. And what we looked at here today are the internal tool set, but we do have an integration with DaVinci Resolve that is able to share the graded, pretty much the whole color page across the render nodes with zero latency. We don't have that set up here today just by practicality, but both tool sets are available. Any more questions? Hello.
I saw in one of your scenes you had some generative particles. Can you speak a little bit to what software was used to generate those?
Yeah. Kyron, can we actually jump back into the abandoned bakery? In this case, all the particles it's actually scripted with GLSL. So yeah, we can use point sprites of any shape, really. And then you can choose how transparency and stuff renders to depth. But yeah, in that case, that's what we're doing here, which is what allows it to work in the depth buffer, so that depth of field actually works with all those floating particles. Otherwise, you would get a lot of artifacting.
Right. Do you have any... So this was using GLSL. I mean, in the pipeline of what it is that you're building, are you making any room for integrations with other commonly used generative tools or tool suites that DCC artists would use?
Yeah, certainly. Like right now, I think we can work out ingesting like notch blocks. But I mean, pretty much anything with a published API or SDK, if the demand exists, can probably be worked into the pipeline, yeah. Yeah. Thank you.
Can you export this to different vendors for like post-viz per se?
Yeah, you can export. We can export EXR, pretty much any number of different video encodings, and then a number of different 3D formats. We're currently kind of on the roadmap is USD interchange, just to kind of smooth that out, make it a bit more standardized. We can do USD import right now, but not export. But yeah, there's mechanisms to, and usually it settled out in a conversation as far as what that exchange looks like, and then we kind of build up into that requirement. But it's not uncommon for assets or also just metadata. Like we can take metadata all the way down to a single frame as far as the entire system state at that frame. So that's kind of another common payload that we'll hand off to visual effects or at post-production. Communicating color grading information, things like that. Yeah. Hi.
have any plans to integrate ST2110 in your pipeline anywhere?
Yeah, absolutely. Mostly once it starts solving more problems, to be completely honest, there's infinite possibilities, but so far, and just for full transparency, like we use SDI for our entire pipeline right now, just by sheer simplicity. And so once 2110 matures a little bit and can act with the same amount of reliability, absolutely, it is very high on the list. Great question, thank you.
Sorry if you said this already, I came in a little late, but do you have like standing sets, like virtual setting sets? Like someone wants to come in, they don't want to film practical because of, weather, light, sound, etc., but they don't have the budget to create custom locations. Is that something that you guys would offer?
As far as like a library of assets?
Yeah.
Yeah, we don't currently. Most of the time it's bespoke for the production. So the focus has been on trying to economize that process of going out, capturing something, and bringing it back into the studio. But it's certainly something that demand exists for. We just haven't approached it yet.
Here you go.
Hi there. So what I saw was very impressive, and I think that what kind of caught my attention was how you could do this off of just like a single node. So like running like a volume this size, you need at least two nodes in an editor. Whereas like you can with this workflow, you can just work off of a single machine, correct?
Yeah, and that's not necessarily true across the board for what we looked at here today, like the scale of assets. Yeah, you can pull it off on a single node. What will start to stack it up is if there's a lot of different video assets or a lot of heavy 3D assets. But for the most part, each node is good for 8K worth of outputs.
Okay, and aside from, I'd say like the performance, like a lot of what I saw, like you can do within Unreal and just normal end display. Is there any other features aside from the performance of just using on a single node that you would say like you would highlight or that is better than the traditional workflow?
Yeah, the main one is ultra high resolution video playback. Unreal struggles a bit with its media framework when it comes to high resolution video playback. And since the system itself is essentially a hybrid of like a 3D compositor and a DI workstation, meets like a playback system, that's an enormous boon for us, is that we can play back up to we've done up to 16K video without it skipping a beat. So that's probably the biggest advantage, I think. And then beyond that, it's just sheer flexibility. Like, and since we kind of committed to building the renderer, if there's a new problem such as G-splats, we're able to integrate it a little bit more quickly than waiting on an external vendor. Beyond that, I think the next up that we don't have a great way to demonstrate here today would be integration with on-set lighting systems. I think we take a very unique approach with that that allows for shared control between the rendering system and the lighting systems. And so far it's been working out really well to kind of balance out some of the wrinkles and challenges of integrating those two systems in the, call it traditional workflows.
So Jared, I have a question.
Yeah.
How do we get our hands on Iris? Or who do we talk to about Iris?
We are offering, let me get back to the slide. We are offering demos early next year. So please shoot us an email and we'll get you in the queue to come in and check it out, or we'll stream online or otherwise get you the information you need.
We have one more question right here.
Thanks. Well, that's really loud. Can you speak a little bit more to the collaboration with the ASC and Panavision? I'm just curious what you guys are working on with them in regards to the system. Thank you.
Yeah, Panavision has supports array capture, so high resolution video arrays with cinema cameras, and then as well as they have lenses that are particularly well suited to virtual production. And then with the ASC, there's working with several cinematographers in collaboration to kind of make sure that the tool set is up to snuff, for a professional production environment. One of which is Craig Keefe here in front, joining us today. Yeah, among others.
Awesome. Well, thank you, Jared. And a huge thank you to Fuse for hosting us this year with Production Summit. We couldn't have done it without them.